Okay, so we're going to pick up on probability again. This time around, we want to make sure we can use set notation to describe the probability statements that we're going to be working with. Firstly, the intersection symbol. So that's this symbol here that some people say looks like an upside down U, maybe looks like an N. It's an intersection symbol. This is going to be used just to show that both conditions are true. So the probability of A intersection B means an item belongs to both set A and to set B. If these are subjects, art and biology, these are the students who study art and they also study biology. They overlap between the two sets. The second symbol we're going to refer to is the union symbol. Now this one looks like a U in its usual orientation. It's the union symbol. This means that an item belongs to either set A or to set B. Now this intuitively includes items that belong to both. So if we're talking about two subjects in school, art and biology, these are the students who study art or the students who study biology, and it inherently includes the students who study both. So you can see the highlighted portion of the diagram. The union will contain more than the intersection. The intersections are strict conditioning, while the union is more lax. And the third notation that I want you to be familiar with is the complement. So we can have the probability of A and we can have the probability of the complement of A. So we might refer to this as not A. So if we take it back to our analogy, the probability of the complement of A is going to be the students who do not belong to the set A, the students who do not study art. So it's everyone except the art students, the exact opposite. So looking at this Venn diagram here, we have two sets. A is even numbers when a die is thrown, and B is prime numbers when a die is thrown. So let's just check that we know the complement of A dash, not A. Which numbers does it represent in this context? It's everything that's not an even number. Next, we have A union B. What does it represent in context? It's anything that is an even number or a prime number. Anything inside any of the circles. And A intersection B, in this context, it's anything that is A and B. Anything that's an even number and also a prime number. The overlap between the two sets, in this case, number 2. Okay, let's try and mix it up a little bit now. A intersection not B. What does it mean in this context? It means an even number that is also not a prime number. So an even number and not a prime number. And now we're working with brackets. Let's think of the bracket first. So A union B, we've seen what that looks like. That's anything that is an even number or a prime number. Anything inside the circles. Well, I want the complement of that. I want it to be not the union. I want it to be everything that is outside of the circles. And in this case, that's the number 1. And let's look at another bracketed expression. A intersection B. In this context, that means an even number that is also prime. So we're back to the number 2. but it's the complement of that. It's everything except that. It's the opposite of that. So everything outside of that section, everything outside of that region that contains the number 2. For the next section of the video, I'm going to show a Venn diagram with various shaded regions. Pause the video each time a new shaded region comes up and see if you can interpret in set notation the region that's been shaded. They're going to come fast, so be sure to pause the video for each new shaded area and have a good think about what the set notation for that shaded area should be. Some of them do have multiple correct answers. Okay, so here we want to make sure that we can shade in regions correctly using set notation, and just a technique or strategy to help you shade in the correct regions. If we were asked to shade in not A intersection B, we want to think of not A and B as separate individual Venn diagrams. They are individual sets, and then we'll see how to combine them afterwards. Not A, B. And since we're looking for the intersection, we want to shade any region that is shaded in both of these original diagrams. So any overlap between these two gets shaded for our final diagram. And similarly for this second statement, I've got not A union not B. First, let's sketch not A. And then let's sketch not B. And since this is the union, anywhere that was shaded on the initial diagram will be shaded on the new diagram. Anywhere that was shaded on either of the first 2 initial diagrams will be shaded on the final diagram.